derivatives. Now, first of all, you have to understand what you're about to do is you're about to go into calculus. And what calculus does is it takes two theories. It takes the theory of limits and algebra, and it merges them. Okay? It takes those two things and it merges those two ideas, and what the result is calculus. Limits, basically, if I have a wall right here. Oh God, I said wall. If I have a wall here.
Build the wall.
Yeah, build the wall. I'm a racist. And I tell you that I want you to take, let's say you've got a 3-foot step. Let's go with 4 foot because it's easier to do the math. Let's go with 4 foot. Let's say that when you step an average of 4 foot. All right, now I tell you, I want you to take steps toward this wall, but each step you take half the previous step. Everybody with me?
Yeah.
So the next step is going to be what? 2 foot. Everybody with me? And the next step is what? 1 foot. And the next step is a half a foot. The next step is a quarter of a foot. The next step is 1/8 of a foot. The next step is a 1/16 of a foot. Will you ever reach the wall?
No.
Will you ever reach the wall? That's the whole theory behind limits. And the answer is no. You will never touch the wall. Now you've got to think about it in that context because you're thinking out of the box. A lot of you go, yeah, you'll touch the wall, you reach your arm out, touch. No, that's not what I'm asking you. I'm asking you is, if you take half, the half, the half, the half, the half, will your feet ever touch the wall? No. Think about it. Well, let's keep going. 16 is 1/32 of a foot. 1/64 of a foot. 1/28 of a foot. And it keeps on going. In other words, you may not be able to take a 1/256 of a step. Okay? But mathematically, you will converge onto the wall, but you'll never what? Touch it. Okay? That is the whole theory behind limits. And if you understand that, then you'll be okay because we've covered enough algebra to choke a horse. So you should be able to merge the two. All right? So, you never reach the wall, but you what? You converge on the wall. You never touch, but you converge. All right? Now that's where the limit comes in. And the limit is, it looks like this. Limit as x approaches 0, blah, 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 and then the function, okay? Now what that means is it approaches the wall, which this is 0. It approaches the wall, but it never what? It never touches it. Now, algebra, there's several things in algebra we're going to use, but the main thing of algebra that we're going to use is this, and this is very important. I might have shown you this before, okay? But anytime we have a curve, and I place 2 points on that curve, and I join those 2 points with a line, well, thanks a lot, technological straight draw. I suck. Let's try this again. Somebody tell me what kind of line do I have here? What's the name of that line? Anybody know? How about any of those people that invented calculus? Any of y'all know? Well, you're not supposed to know the name of the line, but it starts with an S. E.
Segment straight.
Good try. C. A. Secant. Good job.
Oh,
It's called the secant line. Why is it called the secant line? Because the secant line is on the inside of a curve. On a horizontal curve, a vertical curve in engineering is called a chord. Okay? But in mathematics, it's called a secant. Now, our goal in calculus, and write this down in green because it's very important. Our goal in calculus, at this point calculus, okay? Put a semicolon there, okay? Our goal in calculus right now is to find the equation for the slope of the tangent line. At any point in space. Okay, now I'm going a little bit engineering on you, but that's your first part of any calculus. I don't care if it's business calculus or if it's engineering calculus, is to merge the limit theory with the algebra theory and put them together and find the slope of the tangent line at any point in space. Now, let's find the slope of this line. Well, y'all know the slope of the line, and we might have went through this earlier. I'm going to put a point right here. This point right here, we read from left to right. So this is going to be x, and this is going to be what? F of x. Remember, we're not rednecks anymore, so we can't call it y. We have to call it f of x and hold our pinky up. Okay, the second point, and the second point here, well, this distance right here, from here to here, is called h. Some books call it d. All right? So this point right here is not going to be called x, it's going to be called what? X plus h, Hubert. Some people call it x plus d. And then, well, remember the h was in our difference quotient, remember that? Well, that's where it comes from. And then this point over here is f of what? Now I want you to find the slope of that red line. Not with numbers, but with those what I've given you. Use your delta y over delta x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and find the slope of that secant line. Slope of the secant line. Delta y over delta x. This is the way I go over sections that y'all don't know. The first unit was all review, so from here on out, we're going to be going over each unit like we're supposed to. So what is delta y over delta x? That's y sub 2 minus y sub 1 over x sub 2 minus what? X sub 1. So where's our first point? This one right here, and this is our second point. So what's y sub 2? F of x plus h minus what?
F of X.
F of X over what?
X plus H minus X.
X plus H minus X, which is what?
F.
Can somebody tell me what that is?
Oh, it's that.
That's what?
I forgot the name of the formula, but it's the one where you're doing a lot.
That's what we did in the last what? Last unit. It's called the difference quotient. The difference quotient is the what? The difference quotient is the what? The slope of the secant line. Okay, who has a question? Anybody got a question so far? Haven't got to the green yet. We're still on the blue. We're still in algebra land. We're fixing to take the limit theory and we're fixing to apply it to the algebra theory, and then all of you are going to be calculus students. Okay? Everybody understand the left? Everybody understand this side? Yes or no?
Yes, yeah.
Okay? Does everybody understand this is the slope of the red line is the same thing you learned in algebra. You just hold your pinky up, and now you're calling it this. Everybody understand that?
Yep.
Okay. Now, what I want to do now is I want to take these two and I want to merge them together. What does that mean, Hubert? Well, I'm going to draw a bigger graph on the next page. And we're going to do that black. Now notice I am staying in the first quadrant because most of the time in business you want to be, unless you really suck at it, you want to be in the what quadrant?
First.
You want to be in the first quadrant. Okay? So here's my line. And here is my 2 points. And my line well, that sucked. Damn Nigerians. Where's my ruler? I'm gonna get training one day.
Probably not.
Maybe if it's a poster, I might. Okay, so there's the, I'm gonna make the points bigger. Always make the points bigger when you screw up. There you go. All right, so there's your 2 points. And a while ago I said that the slope of that line was the difference quotient. Everybody said yes. So here is X. Sorry about that. Here's X. F of X, sorry. And then here is X plus H. And this is F of X plus H. Now, there's our algebra. And we know that this right here, from here to here, is called H. Everybody understand that? I'm just setting you up because I'm fixing to apply something else to it. That's H. Everybody understand? Some people call it distance, and I call it H because it's easier when you go into another book or another class. It's going to be, in the calculus class, it's called H. All right, so, but I told you that the goal of calculus is to get the slope of the what line? We've got the secant line. So what do they need to do? Well, we need to apply the limit theory. And when we apply the limit as h approaches what? 0. We're going to apply that to this graph. Now, what's that going to do? Well, what is h right here? H is big right here, but when h approaches 0, when I do this right here, limit as h approaches 0, because does everybody agree with me that this is the distance? Everybody agree that's distance?
Yes.
H is distance. So if I bring this point this way, what is the distance doing? It's getting what?
Smaller.
Well, let's see. 4 foot, 2 foot, 1 foot, down to what? Down to, do you ever touch x? No. So is there a thread of distance between x and x plus h? Yes. Let's say it's about 10,000th of a width of your hair. Okay? I'm trying to get you to think out of the box. But it's not touching x. It's a real thin line. But what happens is, this point, when you apply the limit theory, this point comes down here. Then it comes down here. 4 foot, 2 foot, 1 foot, half a foot, quarter of a foot, eighth of a foot, 16th of a foot, 32nd of a foot, 64th of a foot, 128th of a foot, 256th of a foot. And it eventually gets so close that the secant line turns into the what?
Tangent.
The tangent line. And you have just put the limit theory with the algebra, and now all of you are now calculus students. Okay? Because you're taking, I'm going to outline this point. This point is right here. That's the red point. And then the blue point is right here. Now, the distance, y'all say, well, that's a 10,000th of a width of a hair. Okay? Because that limit is gone as far as it can go until it's almost touching that red dot. Okay? And that is where we get this right here. The limit as h approaches 0 of f of x plus h minus f of x over h. And this right here is where you take the limit theory and you add it to the algebra and you get what we call the derivative. And the derivative is the equation of the slope of the tangent line. The derivative is the equation for the slope of the tangent line at any point on the line. At any point on that curve. So if I wanted the slope of the tangent line here, then I could calculate the slope. If I wanted the tangent line here, I could calculate the slope. Now, to see it even more, you can take your handy dandy virtual calculus CD and we can make the tangent. There's our tangent line. There's our x plus h, which that's not where I want it. Yeah, that's not where I want it. Well, do the best we can. There's x plus h. There's the x plus h. And the secant line is right there. And create Q. It's way the heck up there, so I need to move it down. Yeah, it's way up there. Let me, hold on a second. Well, that helps. Not what I wanted, but let me bring this down a little bit. Give me a second. I'm trying to keep it in the first quadrant, and it's not helping. Anyway, Q way the heck up here, okay? And as Q and if you'll tangent segment at T and show let, and you see what's happening. The secant line is slowly turning into the, and I want you to look at it. I mean, I don't want to hypnotize you or anything, but I want you to look at it because you got to think out of the box. What is that H doing? It's going down to what? It's barely touching the wall. It's not touching the wall, but you're getting right up next to the wall. And that distance is getting as close to 0 as you can get, but it's not touching 0. And that's what's happening. And a lot of people don't even see this in calculus. The teacher says, okay, we're going to do the limits, and we're going to do the quotient rule, or the difference quotient, and then boom, this is calculus, and this is how you take the derivative. But what are you finding? You're finding the equation of the slope of that green line when that h gets to be close to 0 as possible. So just look at it, and that's what you're doing. Now we're just going to sit here and stare at it for 15 minutes. And everybody's going to be hypnotized, and I'm going to tell y'all to cluck like a chicken. All right, so that's what you're doing. So let's go back to the whiteboard. Now, with each degree, now, you know, if I change this and make this look like a saddle, and move that X, which is not going to let me move the X, move target X, double click X target. Let's see if I can do this. Let's make, I want to move it. I don't want to move it. I want to move it. There we go. See, now that secant line is turning into the tangent line, but it's going what? In the opposite direction, see? And see, look at the slope. You can tell the slope at that point, any point on the line. And see, that's a lot of things. Another thing that people don't realize about calculus. In algebra, you study things like point by point, all right? In calculus, you're starting to merge points with time. Okay? In calculus, you're starting to merge points, a point in space with time. And that's where you get into the differential equations and the rates of change, because the rates of change have to do with time. And that's something that we cannot what? Change. If that ladder is falling, that ladder is going to fall the same amount of rate of change whether you're on it or whether, you know, there's nothing on it. What falls to the ground quicker, a marble or a feather? They both fall at the same rate. Okay? So you've got to put that in aspect with time, and that's what you're going to be interested, because what in business, what do you not have control over? Time. Whether you keep money in the bank for a year or whether you keep money in the bank for 10 years. The 10 years and the 1 year is going to be the same. if it's 20 years from now or 30 years from now. So you're going to have to deal with this guy sooner or later, whether you're in engineering calculus or whether you're in business calculus. And this is what we're doing. We're starting to say, okay, well, what's happening on this curve at 10 years, at 5 years, at 4 years, and boom, it's giving it to you second by second right here. That slope is changing, and then it's going to a negative slope at a certain point, at that vertex. That's why it's so important for you to know what kind of curve is this. What is this called? This is called the local mean. What's this called? The local what? Max. Okay. You know this is a cubical type or a fifth degree because it's got the opposite direction, ending behavior. It's got an arrow there and an arrow there. You've got a horizontal shift. You've got a vertical shift. You've got a Y. That's why it's so important for you to spend all that time in that Unit 1 so you know what the heck you're dealing with. Because now you're going to dissect this curve in terms of the what? The rate of change. And the difference between the slope and the rate of change is the slope is the slope. But when you apply time to it, a stopwatch, then it becomes rate of change. That's the difference. Okay? So let me put that in perspective. Some of y'all, I can't stand the snow. I can't stand the ice. But some of y'all like the snow and ice and like to go skiing. All right? If you come down the slope, you're coming down the slope. If somebody times you, that's rate of change or rate of descent. You know what I'm saying? If you're going down and somebody times you, then that's called something different than slope. Okay, slope that's just you coming down a slope. But you apply a stopwatch to it, then you're talking about rate of change. Capiche? Now, a lot of you say, well, why is he showing us all this? Because if you don't get any of this, you're going to have a hard time in calculus. But hopefully, I've made you have the transition from the algebra with the limit theory, with this graphic showing you how time is what you're going to be dealing with in the future with Calc 1 and Calc 2, Business Calc 1 and Business Calc 2. Anybody got a question? Anybody ever seen anything like this? Okay, nobody's going to talk to me. Okay, that's fine. No, a simple no or a yes would suffice.
No.
Okay, thank you. One person. Gotta love these one person interactions. Gotta love them. What do they call it? Monologue? Anyway, or dialogue, one of the two. It should be a whole group, but these people don't talk, so I'll just have to do the best I can. Now what are we going to do? Well, we're done. Y'all know calculus now, so sweet. Let's go with an example. Let's go with something simple like f of x is equal to x squared plus 4x minus 7. All right, I want you to graph that. Graph it. Not with your calculator. I want you to go through and find the vertex. I want you to find the y-intercept, the x-intercepts, and then sketch a graph. Write it down because I'm going to go try to see if I can get some kind of representation on that do-jigger while y'all are working. Everybody got it written down? Completing the squares, do that. I'm going to run over here and see if I can get it somewhat -7. That's going to be fun. I should have made it +7. But anyway, here we go. 7. That's x to the 4. I'll be able to do. will. I was hoping I could. Maybe with some training I could do a little bit better. So here we go. Zero, or x squared plus 4x plus blank is equal to 7 plus blank. Half of 4 is 2. 2 squared is what?
4.
X plus 2, quantity squared, is equal to 11. Vertex is -2, -11. Y-intercept is 0, -7. And let's finish it, square root, x plus 2 is equal to positive or negative. Well, 9 is 3, so I'm going to say 3.2. What is the square root of 11?
3.31.
Okay, 3.3. Okay, so 3.3 minus 2 is what?
1.32.
1 point what? 1.3? Right? And negative 3.3 minus 2 is negative 5.3, right? Y'all check my math. So we've got a graph. I don't want it to be this, I didn't want it to be negative, but anyway, the whole point is 1.3 is right here. Negative 5.3 is over here. -7, -2, -11 is down here. 7 is right in here. So let's say we take we'll try to, there's our secant line right there. And you want to find the point there, so we're going to take f of x plus h. So f of, and I need to clear this. Well, just let me do this. Anyway, y'all see what it looks like? And we'll draw it again in just a second. Okay, so I'm going to erase all this now. Keep that drawn and keep it in a, I hope you drew it, somewhat large so you can see it. I hope you didn't draw it like this, like some of y'all do. Here's y'all's blue notebook paper and y'all draw a little line there, and that's stupid. If y'all do that, don't even say nothing. I don't even want to talk to you. Oh, okay, so we got to do f of what? X plus h minus f of x over what? H. Because that is the slope limit as h approaches 0. We've got to do this. So, golly, we're going to that back in Unit 1, Hubert. Yep, we got to take our blue. We'll do it the same way we did then, so y'all won't break the amble with a banana, because some of y'all will. Minus the red, which the red is just f of x. I can rewrite that. That's x squared plus 4x minus 7, because that's this right here, f of x. But we got to rewrite the blue with a big set of what?
Parentheses.
Big set of parentheses. Parentheses squared plus 4 times parentheses minus what? 7. And all that's over what? H limit as h goes to what? 0. So what do we plug into the blue parentheses?
X plus H.
Oh my gosh, there's that shortcut. Shortcut number what? Number 1. That y'all cannot get rid of. And there, so do the algebra. And you all do not suck at algebra because you've been through, when Unit 1, although some of y'all made D's on the test, y'all suck. But the rest of y'all pretty much don't suck at it because y'all didn't make D's and, well, some of y'all made C's. Y'all suck too. X squared plus 2xh plus h squared plus 4x plus 4h minus 7 minus x squared minus 4x plus what? 7 over 8. And what happens to some of your terms? Well, let's take our red pencil. Is there another x squared anywhere? Oh, look at there. Cancels. Okay, what else cancels? 4x cancels. 7's cancel. And what are the only things that are left? All the h terms. So write those down and go ahead and factor a h out of the top. So that's going to be h, and that's going to be 2x plus h plus 4 all over h. And what happens to the h's? So now we're left limit as h approaches 0 of 2x plus h plus 4. And what happens when you plug in 0 for h with this term right here? I'm going to do that in green because that's a limit. As h approaches 0, what happens to this h? It turns into what? 0. So what's left?
2x plus 4.
And that is the equation of the slope of the tangent line on that curve. We're going to go back to it in just a minute. 2x plus 4, that's our answer. And that is what we call the derivative. The derivative. The derivative is a 25-cent word for the equation of the slope of the tangent line at any given point on the curve. Want to write that down? That's very helpful. The derivative is a 25-cent word for the equation of the slope of the tangent line at any point on the curve. Question? Right, complaint. Okay, so what do we do with that, Hubert? Well, we write it over here, and I erase this. And we're going to write it right in here. We're going to put y-intercept is equal to 0, negative 7. What was the vertex? I'm asking y'all to interact with me.
Negative 2, negative 11. Negative 2, negative 11.
Thank you. And our x-intercepts was
negative
1.3.
Yeah, negative
and
5.
What? Negative 5.3.
Yep.
Okay. And our derivative is equal to 2x plus 4. Okay, now I'm going to erase all this. Now see, when you're in the first quadrant, this stuff is going to help you when you're not using a calculator or a computer. All right? That's what all that calculator and computer is based on this stuff over here. So let's draw the graph again, sketch it. And no, you're not going to have to do this with each one of your problems, no. Now, you will have to do the x plus h, but the reason I'm doing this all long and drawn out is because this is very pivotal. If you go into this unit not knowing what we're doing, you're going to be lost the rest of the semester or the rest of the units or whatever. You're going to be lost. So this is very important. So we got our graph. We said 1.3, negative 5.3, and negative 2, negative 11, and 7, somewhere in there. And let's say I give you a point, and we make it blue, and I give you this point right here. And that point, we know this is negative 5.3, so we're going to say that point is negative 5. Then you can tell me what? You can tell me the slope of that blue line at x is equal to negative 5. So you go over here and you say slope of the tangent line at negative 5 is equal to 2 times negative 5 plus 4. What's negative 2? It's negative 10 plus 4, which is what?
Negative 6.
Negative 6, right? So the slope of this line is negative 6. Let's go over here. Let's say you put a point right here. And you say that this point, you know this is what, so this is x is equal to 2. So the slope at the tangent line where x is equal to 2 is equal to 2 times 2 plus 4, which is 4 plus 4, which is what?
8.
So the slope of this line is equal to what? Somebody figure the slope of the line at the vertex. What should it be?
0.
Should be 0, so let's check it. So what is the 1 point, what is the x? Negative 2, right? So
Yep.
at x is equal to negative 2, the slope is equal to 2 times negative 2 plus 4. Negative 4 plus 4 is a miracle.
Is that constant
0.
every time?
You tell me.
Always? I believe so. So we can always use that to just check our answer.
Exactly.
Right.
Good job. Wow. You're actually, I need to sit down. You're actually, what's it called? Thinking. Good job. I'm impressed. So now we're just going to do a bunch of derivatives now. But I'm going to show you a trick I learned in the war. You can actually write this in some weird color because it's very important. I'm going to do it in green. You can take this exponent and you can put it out front and drop it by 1. And that's derivative. So, what's 2 in front of x? 2x. What is 2 minus 1? First power. Plus 4x to the 0. Okay, or x to the 1, sorry. Plus minus 7x to the 0. So let me start over. Because I put it in the wrong place. Hold on a minute. Put x's on each one of these terms. Well, that's x squared. This is x to the first. And this is x to the what? 0. The rule of derivatives in calculus is that you pull the exponent out front and you subtract 1 from the what? From the exponent. So pull this out front, subtract 1, pull this out front, subtract 1. So what's 2 out front? That'd be 2x to the first plus, what's 1 times 4? 4. What's x to the 0? Well, that goes away. What's 0 times 7?
0.
2x plus 4 is our derivative, whatever I had written over there. So you can actually find the derivative two ways now. With the difference quotient, which you're going to hate after we get through doing 5,000 problems, and the easy way, which is your new power rule. Derivative power rule. Derivative power rule, and we'll put it in upty-dupty, hold your pinky term. You know, we'll do that later, okay? Right now, I want you to see what you're doing. Capiche?
Yep.
All right, let's do nerd. Let's do f of x squared. I'm sorry. I'm on drugs. F of x is equal to, let's go with 1/2 x squared plus 2x minus 6. Now you don't have to draw the graph. I just want you to do the difference quotient. Just do the difference quotient. So that means limit as x as h equals 0 of f of x plus h minus f of x over h. And if you can't do it, just write it down as what? Being a disappointment. Miss Shuttleworth, you awful quiet. You all right?
Yeah, I'm good.
You're not spazzing out on me, are you?
No, sir.
Miss Youssef, you still with us?
Yeah, I'm okay.
Okay. I got to check on each. Coney, you still with us?
Yep.
Y'all don't get too excited. Yeah, I know. Y'all are blessed to have a teacher that goes through all of this. Yep, you are.
Man.
Y'all want amen. Y'all suck. See, that's why y'all going to fail in life. All right. And live in a van down by the what?
River.
Down by the river. All right. Some students have no idea what I'm talking about. That's their parents' fault. It's not mine. Google. What's his name? Matt
Chris
Foley.
Please.
Matt Foley. If you don't know what I'm talking about, you need to Google Matt Foley. And show it to your parents so they'll know where they came, didn't do their job. All right, so here we go. Big set of parentheses. And of course, we just do f of x here. 1/2 x squared plus 2x minus 6. And plug in, I'm going to do that in green. Plug in x plus h and x plus h. And that's going to equal, well, we know x plus h squared is x squared plus 2xh plus h squared. So 1/2 x squared plus, what's 2 times 1/2 times xh? Xh. Thank you, class. Plus 1/2 h squared. Plus 2x plus 2h minus 6 minus 1/2 x squared minus 2x plus 6 all over h. And what cancels? Well, the 6 cancels, the 2x cancels, and the what? 1/2 x squared cancels. You're left with h times x plus 1/2 h plus 2 over h. And what happens to the h's? They cancel, and you're left with the limit as h approaches 0 of 1/2 h plus x plus 2. And what happens to the 1/2 h? What's 1/2 h times 0? 0. And your derivative is x plus 2.
I have a question.
Yes, sir.
Since you showed us the quick way to do it, is there ever a good reason to use
That's what I'm getting to. Good job. Good observation. Who made that? Who made that observation?
I did.
You're doing good today. Because basically the derivative law, or the power rule of derivatives, basically saves you from having to what?
Use your brain.
Do all this work. But you can't appreciate it until you do all the work. So I'm going to make you do all the work so you will appreciate it. Let's check the power rule and let's see what we get. But if you're making that observation, you're getting it. Good job. So here we go. I'm going to rewrite it. 1/2 x squared plus 2x to the first minus 6x to the 0. Now I want everybody to use the rule I gave you. Bring the exponent out. Subtract by 1 all 3 terms and see what you get.
There's no x on 6.
I know it's x to the 0. What's x to the 0?
Like fake.
I'm doing it for a reason.
Yeah, so you just like write it in. Okay.
That way you'll never get confused. A lot of people are like, why do you do that? The reason I do it is because a lot of people, if I say f of x is equal to 6, and I asked you for the derivative of 6, you'll sit there and go, I don't know. But if I put this in front of it or beside it, you'll know what to do. And then when I say that the derivative of a number is 0, you'll understand why. So, what's 2 times 1/2?
1.
You're so smart. Plus, what's 2
went
times
to college.
1? You going to college? I went to college. Who says that? Plankton. What's x to the 1 minus 1? X to the what? Wait a minute. Yeah, 0, which is 1. And what's 0 times 6 times anything?
0.
So your answer is x plus what? Same thing as this one. That's how you check your work when you're doing the difference quotient. If you come up with a difference quotient of 5x plus 6, and you come up with a derivative of x plus 2, chances are, where is the error in your algebra? You don't suck at calculus. You suck at the algebra before the calculus. No sneezing in class. All right, let's try nerd. f of x is equal to, I'll be easy on you, 2x squared plus 4. So go ahead and put it through the difference quotient. And then we're going to talk about fancy stuff. I do not want y'all doing any homework tonight, except for doing problems like I'm doing. Because I don't want you to use the book or the questions on WebAssign, because they'll do nothing but what? Confuse you. So I'm going to wait another day before I assign the homework for this. But you can make up questions and do, if you do 5 or 10 questions, just make them up. You should be okay, because you can always check them with your calculator. Oh, veterinary technology is giving away cats. Billy Bob. Lord, I can't have another cat. I'll be known as the cat man. This one shouldn't be too hard. So somebody tell me what the derivative is. 4x. Oh my gosh, I did it that quick. No, I took 2 times 2, and that gives you 4x. And the derivative of any constant is 0. Derivative of 4 is 0. So, how do you know it's 0, Hubert? Well, what's this? X to the what? What is 4x to the what? 0. 0 times anything does what? Takes that whole term out. So the derivative here is 4x to the first, which is 4x. So that's the derivative. Now let's check it. So 2 parentheses squared minus 4. That's f of x plus h. Minus f of x, which is 2x squared plus 4, over h, 2x squared plus 2xh. Well, that'll be xh because the 2 cancels with the half. So that would be 2, the half xh. Plus 2h squared minus 4 minus 2x squared minus 4. 4's canceled, 2x squareds cancel, over h cancels there, x plus 2h over what? Well, I already canceled that out. I think I've got something wrong. Something's wrong.
Did you not distribute to the XH?
Yeah. This is going to be x squared. Oh, there it is. I forgot I did 1/2. I'm sorry. That's supposed to be 4xh. Right? There we go.
Yeah.
There we go. But you see, the whole point of doing both of them is so you can catch your errors, depending on where you're from. Okay, so that's going to be 4x plus 2h, right? 4x plus 2h, and limit as h approaches 0. And what does that do to the 2h? What does the limit do to the 2h? 2 times 0 is what? 0. So that takes that out. So you're left with what? 4x. Now, if you was to graph 2x squared plus 4, any point on that line, what's the slope? What's the slope at x is equal to 2? 8. What's the slope at x is equal to -3? -12. So you know at any point, let's see, this has got a y-intercept of 4. I don't know if it has any x-intercepts, but let's check it. 2x squared plus 0x plus 4 is equal to 0. 2x squared plus 0x plus blank is equal to -4 plus blank. I don't think it does, but let's go ahead and pull it out. 2x squared plus 0x plus blank is equal to -4 plus 2 times blank. Half of 0, 0, 0 squared is 0. -4 plus 2, so it doesn't have any x-intercepts. X plus 0 quantity squared. It's going to be 0 and -2. 0, -2. Let me check that. Hold on. -4, -1. Anyway. -2 would be -1. X plus 0. Okay, 0 and 1. 0 and 1.
Can't have any because one's negative and you can't have the square root.
I know that, but I'm trying to find the vertex.
Oh.
The vertex is 0 and +1. But it's...
Yeah.
Can't have vertex, and it's got to be, I don't know what's going on. Somebody graph it and tell me where the vertex is. But anyway, you have I don't know which it's on this side or this side. I don't know which one it is. But it doesn't have an x-intercept. I've got something wrong. Something's wrong in here. So somebody graph it and tell me where the vertex is. Is it on the right or the left? Can somebody graph it right quick? Nobody's got a calculator? Nobody's going to graph it for me? Appreciate the help. I don't know where I got the error.
It says the vertex is 4.
Okay, well, I must have done something total. Oh, that's nice. -4 plus 0 is -2. That's real nice, Hubert. You really suck. Sorry. Oh, thank you.
Welcome.
That's what happens when you get in a hurry. Okay, so 0, 4. Well, that still doesn't help. Because that still says we have an x-intercept. Where's the vertex? Somebody graph it. I still got something wrong on there. I don't know what I've got wrong. Something's wrong. That's all right. I'll do it. Evidently, y'all have gone dumb or lazy, one of the two, on the calculator, so I'll just do it. Appreciate the help.
Try my best.
2x squared, graph, F 2x squared And don't you dare say anything now. As soon as I grab it, somebody's going to say, oh, it does. Shut up now. Squared plus 4. Okay, it is right. Oh, the y-intercept is the same as the vertex. That's it. That's why I couldn't get it right.
Yeah.
My bad. All right, so if I give you a point over here, let's say that's -6. -6 is going to be negative what? -24 slope. If I give you a +8, +8 is going to give you a slope of what? 32.
32.
And you should be able to do that. Now, why is this so important? Well, in business, what time is it? Somebody tell me before somebody goes into convulsions.
10:48.
How much?
10:48.
Okay, that's exactly where I wanted to stop. All right. And whatever you have, or if you have a line coming down through here or whatever, but what we're leading toward is this. Your demand curve, well, let me go backwards. Your supply curve looks something like this. Your demand curve looks something like this. This point right here, dang old John Nash, dang old beautiful mind, equal what? Equilibrium. Equilibrium, also called market equilibrium. At this point, we can find the slope at this point. Now, what is that? The slope is the rate of change at this point. Rate of change means something very good. It means basically that for every 1% price increase, the demand will either go up or what? Down, depending on what that slope is at that point. Everybody with me? That's where we're headed. That's where we're heading in chapter 6 and all that good stuff. So, and then that's called the derivative. So over here, we're going to use the what? The derivative to find the slope at that point. Over here, we're going to take I don't have it drawn exactly right, but right here and right here and up here, right here, we're going to have a consumer. We're going to have a consumer surplus and a supplier surplus or whatever.
Hubert,
Yes.
you misspelled consumer.
Whatever.
I'm offended.
Let's see. Can you spell this? There. All right. This right here is called the consumer region, and this right here is called the supply region. And here we're going to use what we call the integral, or the what? Antiderivative. So that's where all your calculus is going to come in. But you can't understand the antiderivative unless you understand the what? Derivative. So we're going to spend a lot of time on derivative in this unit. Okay? Capiche?
Peace.
All right. Now, what's the homework for tonight? Well, don't say nothing, because that's not true.
Oh,